evolution didn't happen overnight. This theory came about after years and years of thought by many different people. But it really helps to start with an basic understanding of what this theory is all about, so all of these building blocks make a little bit more sense. So let's start with, what does evolution explain? Take a moment. Can you answer this in your own words right now? After you've tried to give your own answer, here's mine. Evolution explains observations about changes in living organisms. One of the most beautiful things about the natural world around us is things are constantly changing. And evolution is how we explain how living species have been changing for millions and millions of years. The word evolution, it simply means it came about from the word, a word meaning unfolding, but really now we call it to change over time. When you use the word evolution, you want to think about what is changing and how are you measuring time, because you can use the word evolution in a variety of ways. So if someone changes their opinion on an important matter, we can say their opinion evolved. Obama got a lot of flack for this a couple years back, well, more than a couple years at this point, when he changed his stance on same-sex marriage. But that's what adults do. They change their opinion with new information. Thanks, Obama. But let's get back to talking about biological evolution. So here is a really lovely quote. Animals engage in a struggle for existence, for resources, to avoid being eaten, and to breed. Environmental factors influence organisms to develop new characteristics to ensure survival, thus transforming into new species. Animals that survive to breed can pass on their successful characteristics to offspring. This is a really lovely quote about evolution, and it describes it pretty well. Like, we are competing for resources. Resources are limited. And the environment around us encourages certain things to evolve, or certain characteristics and species to evolve. You might think that this was a quote by Darwin himself, but in fact, this is from an Afro-Arabian scholar from Iraq, Al-Jaziz, much, much, much earlier before Darwin. So you can see a lot of these base observations about the natural world had already been made before Darwin came around. And there are a couple of key observations that we see that support the theory of evolution. First, we notice that species are in general well suited to their environments. We see deep similarities between different species, and we have this enormous diversity of living things, and we have fossils. So let's talk about these 4 key observations. Many species are very well suited to the environment with which they live in. Let's talk about some desert species, because deserts are pretty harsh environments and they require some more extreme adaptations to survive in them. Let's start with our camels here. So they can actually close their nostrils to protect against blowing sand. Sand is not fun in many places, one of them being your nose. They also have these beautiful 2 rows of eyelashes to again protect their eyes from sand. Like, sand is no joke. They can store water and fat in their hump, so that means they can survive for really long periods of time without food or water. Their long legs keep their body away from the hot sand, because that sand gets really, really hot. And their feet are actually really big. They have these broad pads so they don't sink in the sand. They have built-in snowshoes. But it's also not only camels. Many desert plants are very well suited to this environment as well. So they have this really large fleshy stem with which they store water. They don't have leaves, so they reduce their surface area to prevent as much evaporation as possible. They have this thick waxy cuticle to prevent additional water loss. They have these prickly spines to deter herbivores from eating them, because if they are bitten into, now they're going to be losing a lot of water. And they have this super large network of roots because they want to store water. You can see all of these features are really helping with water retention and preventing water loss. And no matter what species you look at, you're going to find a similar array of features that support the survival in the environment with which you find it. When we compare different species, we also see very similar internal structure. So this is looking at similar muscular structure between different tetrapods, and also comparing it to a fish. If you look at different organisms, even if you look at plants, you would also find a lot of similarities there. So seeing this similarity in structure suggests some common origins. We can also look at similarities in bones. These bones here are colored, so each the same bone has the same color in these different organisms. You can see that it's in drastically different forms. So right here we have our humerus. The humerus is shorter in our cat here, but it's a little bit broader at that top. And in the whale, it is super short and broad. They have made most of their bones really short in their forelimb, but they've elongated their fingers or their phalanges there. Our bat is much more slender, and you can see they've elongated their phalanges, and they actually fly really with their hands. So bats take flight with the power of jazz hands. And next, there is just an immense diversity of living species. There are so many different living things out there. And if you go to a different place, you will see different species. This was especially noticed in the European age of exploration because we had a bunch of people who were leaving Europe and now going to entirely different parts of the world and seeing that there are different species in different parts of the world. And with these different species, we had to do something with it. We also noticed that some things that looked similar, we actually started to recognize that they were not the same. So Cuvier was the person who separated Asian and elephant species into different ones. You can see we have our Asian elephants have a little bit of a hump on their head, and African elephants have more of a sloped forehead here. A little bit more subtle, but you can see they also have slightly different tooth morphology. We can also look at them in profile and see that they are a little bit different, but here we are comparing them to some extinct species, the mastodon and woolly mammoth. Now that we're starting to recognize all of these different species, as is human nature, we started to classify them. We talked about this a little bit already, but Linnaeus started to put these species into a classification system in the Systema naturae. So in 1735, he did his first edition, which is so adorable. It was 11 pages. But of course, he had to improve on this. And here is Linnaeus, born Carl von Linné. It was the fashion of the time. Everybody Latinized their name, so instead of Linné, he's Linnaeus. And he made so many different editions, and this 12th edition is the one that we base our modern systems of taxonomy on now. It was over 300 pages. So that is how many more species were discovered in the eyes of Europe, at least. It went from 11 to over 300 pages. The modern version, or the Natuurlyke Historie, this is a Dutch publication, and it's based on the 12th edition, and it is over 8,000 pages. At this point, we don't really bother with putting everything in print like this because we have the internet, and it makes a little bit more sense because our understanding of different species and what they are is constantly changing. So, let's try and not kill as many trees through trying to catalog the diversity of life. And also remember that through this, we named a couple different species of humans. This was what Linnaeus originally named, but really we are all the same species here. If you're curious, this is how taxonomy might look. So this is the taxonomy of the Western tarsier Cephalopithecus bancanus. These are the ones from Sumatra and Borneo. So we tend to only use the first letter of the genus name when we're talking about it in multiple, one after the other, and we do also have subspecies designations in some instances. These other names here, that is the person who first named that thing. So Swainson is the person who named the genus Cephalopithecus, and Horsfield is the person who named the species Bancanus. So if you see these names like that, that's what they all mean. But let's talk about some fossils. Fossils are interesting because once we find them, they're telling us that this species lived here when it doesn't live here now. And that is very different than what the assumptions of essentialism. And this is direct evidence for extinction because it's showing us species that don't exist now at all. this is a humongous change to essentialism because if species are immutable, then they shouldn't go extinct at all. So this was a huge chink in that chain. Here is an interesting quote from Cuvier. Everyone knows that bones of enormous animals are found underground in Siberia, Germany, France, Canada, and even Peru, and that they cannot have belonged to any of the species that live today in those climates. The bones that are found, for example, throughout the north of Europe, Asia, and America resemble those of elephants so closely in form and in the texture of the ivory of which their tusks are made that all savants hitherto have taken them to be the same. Other bones have appeared to be those of rhinoceroses, and they are indeed very similar, yet today there are elephants and rhinoceroses only in the tropical zone of the Old World. How is it that their carcasses are found in such great numbers in the north of both continents? And that is one of the questions that plagued Cuvier and his contemporaries. They weren't quite sure how to interpret finding species where they don't exist today because that did not fit with the base assumptions of essentialism. So, can you define? What is the definition of evolution? And what is evolution trying to explain?